Hey guys, this is Einar. I hope you're doing great today and welcome to this tutorial concerning the standard deviation for a grouped dataset. Now to begin with, I know it looks slightly different, the working area we're working with here compared to the earlier tutorials, but that's because I'm using OpenOffice on my Mac. So don't mind that, it's going to be the same and all of these things we're doing now is going to work just fine in Excel as well, so don't worry about that. We have our frequency table with our ages, which is the same age material we've been working on from before, and we have a new formula for the standard deviation. It's a really good formula because it takes these frequencies into account that we're going to be working with. Now, what does this mean? What do I mean when I say with frequencies? Well, what I mean is that we have 8 people here in a range of ages, so they're in the same class that consists of people that are 10 to 15 years old. So we have no single number to represent each observation in this class, and we're going to need that in order to place them in the formula. So what number could we give all of these people that will be common? What is the best number to use? Well, it is the centermost point of this class. So what we're going to do is we're going to write equal to. We're going to take the lower class limit of this class, which is 9.5. We're going to add that to the upper class limit of this class, which is going to be 15.5, and we're going to divide that by 2. So we get the center, so to speak, of this class, and all of these frequencies are going to be represented by the age of 13. So if a person here is like 14 or 15, they're still going to be represented by the age 13. I'm going to repeat this for all of these, and I have to do it manually, so just bear with me while I do some calculation. Let's hope I don't forget any parentheses. Divided by 2. I'm just gonna roll through this really quick. I think you've understood basically what we're doing. There we go. There we go. So these are our class centers, and these are the ages that our frequencies are going to be represented by. Next, we want to multiply f by x, because in this part of the formula we're going to have the sum of all the frequencies multiplied by their class centers, and then we're going to raise it by 2. So let's get to work on that. We're going to take the frequencies multiplied by their class centers, and this time I don't have to do it manually, I can just pull it down like this, which is very convenient. I'm gonna so actually we can just sum this up now and raise it by 2, and I'm gonna do it right now so it gets really clear. So I'm gonna equal to sum all these frequencies here, and we're gonna raise that by 2. So this formula here is equal to this part of the formula that we're calculating. It's the sum of all the frequencies multiplied by the class centers, and then we're going to raise this by 2. That's why the parenthesis here is outside the summation. That's a difference. It's an important difference between this one, and that's the most common mistake people make when they're calculating this. So bear that in mind. So we get a number there, and that's excellent. Now we can start calculating this part of the formula, which is the sum of x raised by 2 multiplied by the frequencies. So first we're going to have to raise all the class centers by 2. Get to work on doing that, and then we're going to multiply them by f. So we're equal to our frequencies multiplied by class centers raised by 2, and as before we can just pull it down all like the way there. We want the sum of these for our entire data set, so I'm going to go into my calculation square and write equal to sum, and I'm going to sum all of these numbers here. And we have our 2 most important parts of the formula. Finally, we need our n, which is the number of observations, so I can just sum our frequencies here, and we get 25, which is the same as our total, so we've done it correctly. We now have all the different parts of this formula over here that we need to calculate the standard deviation. Now, you might notice I've entered the variance here too. I did that because, well, the variance basically is the same calculated using the same formula, except we're not using the square root, which is why we call it S2. It's actually S raised to the power 2. So I'm going to start by doing that. Equal to, we need a parentheses, and we're going to take 1 divided by another parentheses, n minus 1 and we're going to close that parenthesis there. So we've calculated this part of the formula. We're now ready to calculate this part of the formula. So I'm going to multiply that by another parenthesis, the sum of f multiplied by all the x's raised by 2. These are our class centers raised by 2, which is going to be this upper one here. So here, sum f multiplied by x raised by 2. So we just highlight that, minus, need another parenthesis there, and we're going to have the sum of f multiplied by class centers and then raised by 2, divided by our n, and I'm going to close that parenthesis and then close it again. I think we have all the parentheses we need. Yes, we do. Hit enter and we get our variance, which is 56.64. Now in principle, the only thing we haven't done is take the square root out of this result. So I'm just going to put it right here next to the next calculation we make, so you can see that that is true. So if we write the square root out of our variance, we get a standard deviation of 7.53. If we calculate it manually though, I'll do that too, so you have all the proof in the world that this is actually the case. So we need two parentheses here. We're going to calculate this part of the formula now, so I'm going to write 1 divided by another parenthesis, n minus 1. Close that parenthesis, close that parenthesis. We now have this part of the formula and we have the square root, and we're going to multiply this by this part of the formula here, multiplied by another parenthesis. This number here, f multiplied by the class centers raised by 2, which is going to be this number here, minus another parenthesis, this part of the formula here, f multiplied by the class centers and then raised by 2, divided by n, and we need two parentheses there, and finally a third parenthesis because we're drawing the square root over this. So if I hit enter now, we get the same result as here. So that proves to you guys that what I'm saying is true here. Now you'll notice that this 7.53 is different from the 7.56 it was in the previous tutorial for the ungrouped data, and the reason for this is that we're losing detail in our material, so we're going to have a difference here. The detail that we have lost is attributed to the fact that all of these 8 people here in this frequency are represented by the age category 13, but in our ungrouped material they actually had their true ages. So the people who were 10 years old were represented by the age of 10, and the people who were 15 were represented by the age of 15. So that's the reason they are different. Basically, that's how you calculate the standard deviation for a group data set. Have some fun with this, try putting in some different numbers and seeing what happens. And I hope you have a really great night, and I'll see you later. Bye bye, guys.